Imagine you're there. It's 1812, and you're a soldier with one of the largest land armies ever assembled, Napoleon's Grande Armée, some 600,000 units strong. Up until this point, the army was the envy of the world, thought to be nigh invincible. And all you had to do was march east, defeat the Russians, and reap the rewards of a successful campaign. What you would not have known, could not have known at the time, was that you were about to be part of one of the greatest defeats in history, that out of every 100 soldiers marching east, just 3 or 4 would make it home. There's a famous chart created by Charles Joseph Menard. It's taught in data visualization classes everywhere that displays the disastrous march. Plotted on a map of Eastern Europe, the width of the line shows the size of the Grande Armée, starting from the Niemen River in Lithuania. The line shrinks in size as the army marches east, eventually taking Moscow, though the city was abandoned and largely burned by then. And then the winter set in. The army retreated west, losing hundreds of thousands along the way. Over 2 months, the army was reduced to 1/10 of its original size. The classic teaching is that it wasn't combat that led to the more than 95% casualty rate. No, most of your compatriots, had you been on that brutal march, died of exposure, starvation, and, above all, disease. If you'd opened a history book prior to last Friday, you would have found a compelling argument that most of the men in the Grande Armée died of epidemic typhus. Epidemic typhus is due to infection from Rickettsia prowazekii, which is carried in the feces of the body louse, a common camp companion in pre-modern armies. The symptoms of epidemic typhus, fever, delirium, and diarrhea were well documented in the diaries of physicians caring for Napoleon's army at the time. But as it turns out, those history books may be wrong. I'm always fascinated when old medical mysteries get solved by modern science. I know the clinical applicability of what we're talking about today is limited, but every once in a while it's fun to take a break from the current epidemics to talk about those of the past, and perhaps to be grateful that we live in, if not a more civilized, a gentler time. 2 lines of evidence laid the base for the narrative that epidemic typhus was the major killer of the Grande Armée. One was contemporary physician diaries, which describe symptoms that fit the disease, and given that body lice were clearly common in the close and rather unsanitary quarters of Napoleon's forces, good old Rickettsia prowazekii got the lion's share of blame. The other line of evidence pointing at Rickettsia comes from this paper from 2006 by Didier Raoult. Yes, that Didier Raoult. In 2006, he was applying state-of-the-art technology of the time, PCR, to body lice found in the graves of Grande Armée soldiers buried in Lithuania. He found Rickettsia prowazekii, epidemic typhus, as well as Bartonella quintana, the agent of trench fever, which was also louse-borne. But the catch here is that at the time, they could only use PCR to search for things they knew they were looking for. Like they had to ask, is there Rickettsia here? And then get an answer, as opposed to what we can do now with next-gen sequencing, which is to ask, what is here? It's the latter question that researchers led by Nicolas Rascovan and colleagues from the Pasteur Institute in France asked in this paper appearing in Current Biology. They examined the remains of soldiers from the same mass grave used in the prior PCR-based paper, a grave of at least 3,269 individuals in Vilnius, Lithuania. They ensured that they were testing the remains of people who did not die from combat fatalities, ruling out skeletons with evidence of gunshot wounds, blunt trauma, or other injuries. The sample size in the end was 13 soldiers. Where to get the DNA from 2-century-old skeletons? From their teeth. Like that scene in Jurassic Park, the scientists drilled through the hard enamel to reach the remnants of pulp inside, where DNA is somewhat preserved. Each of the teeth extracted yielded 20 million DNA reads. They were fragmented, though, as expected from ancient DNA. They had broken down into chunks about 50 base pairs long. That's still enough to look for matches, though. The data were compared to a database of DNA from 185 known human bacterial pathogens. To avoid false positives, the researchers only concluded an infection had been present if more than 200 reads uniquely matched that particular bug. Even then, the researchers engaged in several other steps to avoid false positive findings, including reconstructing the evolutionary history of these bacteria to be sure that what they found could plausibly have existed in the time period these soldiers died. With that, we can come to the reveal. Would the history books hold up? Epidemic typhus? Rickettsia prowazekii? Nope. Not at all. In fact, across these 13 soldiers, the researchers found no evidence whatsoever of epidemic typhus or trench fever. But they didn't come up empty. What killed these soldiers? Primarily, it was salmonella. 4 individuals studied tested positive for Salmonella enterica paratyphii. This is the causative agent of paratyphoid fever. Think of it as a supercharged salmonella infection. This would have been caused by consumption of fecal contaminated food and water sources. Not a stretch, considering the camp conditions. And don't be confused between typhus, the louse-borne disease, and typhoid. That word root, typhos, comes from the Greek for stupor or delirium. The similarity between epidemic typhus and paratyphoid fever is that they both cause altered mental status. Bacteriologically, though, they couldn't be more different. The body lice are not completely off the hook, though. 2 of the 13 individuals examined tested positive for Borrelia recurrentis. That's the spirochete responsible for louse-borne relapsing fever. This is usually not fatal. And 1 soldier with relapsing fever also had salmonella. But I imagine this additional infection didn't make survival any easier for soldiers who were no doubt cold and half-starved to begin with. To be sure, this study doesn't answer all our questions. Their robust methods to eliminate false positives likely eliminated some true positives as well. We're not sure why 8 of these soldiers died after all. But it does seem like the classic explanation for the deaths, epidemic typhus, bane of armies, ancient to pre-modern, may be losing support. While unsanitary camp conditions are ripe breeding grounds for lice, they are also perfect places for the transmission of infections via contaminated food and liquids. It's interesting to consider that in 1812, no one in Napoleon's army or the world understood the germ theory of disease. They were still a few decades away from that. And yet, what defeated one of the largest armies ever assembled was not their human enemies, but the tiny invisible ones that have been the real scourge of humanity since time immemorial. Perhaps the reason a study like this is relevant today is that it can remind us who our real enemies are. For Medscape, I'm Perry Wilson.